Great. Okay, so welcome everybody to our Decadal Survey event, sponsored by the, well, not really sponsored, but organized, helping co-organized by the American Physical Society Division of Biological Physics. We have a community engagement team that is planning a series of roughly monthly events. August is special, we have two. And so before we get started today, I just wanted to briefly share some information about that in case you're interested in future events. So you go to the home screen of the American Physical Society Division of Biological Physics. You can click on the workshops and networking and see the variety of events that we've been organizing and will be organizing in the near future. If you've missed any of the events that have happened so far and you're interested in them, you can click, that is not a good example because it's not posted yet. You can click to view the recording of the event. The recording of this one will also be posted afterwards. And I would encourage you, if you're interested, to sign up for our event later this month on teaching biological physics, same time, different Zoom address. So please register, and we'll see Bill Bialek there as well. And the other one open for registration at present is communicating biological physics. And Raghu Parthasarathi is also in the audience here, and he'll be one of our panelists at that event. So if these are interesting to you, we would love to see you at the events, and if you have suggestions for upcoming events in the series, do reach out. Otherwise, it's my great pleasure to be sort of moderating this event and have this opportunity for all of us to learn a little bit more, if we don't know very much already, about the results of this decadal survey, and then to have an opportunity to learn about what it is that we as a community can do to help implement the recommendations of the survey. And so we have three members of the original committee with us today. We have Bill Bialek, who was the chair of the committee, Peter Littlewood, and Olga Dudko, who are members of this and put a lot of work into surveying the community and then drafting and writing this report. So I'm going to turn it over to Bill. At this point in time, I will be just sort of monitoring the chat if any questions come up during, and then afterwards I can help to coordinate the Q&A. But otherwise, I'll turn it over to Bill.
Thanks, Nancy. It's a pleasure to be here. I say that on behalf of my colleagues as well. I thought I would take a few minutes at the beginning. My guess is that the audience at an event like this is enriched in people who have actually been paying attention to this process. So I don't want to go over everything, but just to a few reminders. This report on the physics of life is the first time that biological physics has stood on its own as part of the general Decadal Survey of Physics. This started a long time ago. And as the name suggests, roughly once every 10 years, there's an effort which is implemented by the National Academies to take a look at the state of physics research, the challenges, funding, and so on. In order to make the task manageable, it's broken into pieces. In the 2010 cycle, there were 6 pieces. Some parts of the community use this process in a very special way. So if you've been enjoying the images coming from the James Webb Space Telescope, you should know that that is up there in part because many successive decadal surveys of astronomy and astrophysics placed it as one of the priority projects. Our friends in that field use the decadal survey process to set priorities for the field for funding, which thankfully we were not asked to do. There's a few things you should know about the process. One is that it's not just a bunch of people in a room expressing their opinion. We are actually asked to do something, so we're responding to a set of questions. These reports are consensus reports, so all of us will commit what is otherwise the unpardonable sin of speaking in the plural, because we speak for the committee. You're not hearing the opinions of individual committee members. It really is a consensus, and we all stand behind all of it. In order to get there, among other things, we gathered community input. Many of you probably provided some, hundreds of people did. And the whole thing undergoes peer review. We have almost as many reviewers as we have committee members. And that process is very carefully monitored by the Academy. So the we is not only the consensus, but there's a whole bunch of us. We were 13 committee members. Olga and Peter are with us today. Chris Jones is here representing the Academy staff who made a lot of this possible. This was our pandemic project, so you can imagine that there were a number of challenges. The report, as I say, responds to the questions we were asked, and so the response comes in this outline. This website is where you can find the document itself. As many of you probably know, there's also a beautiful sort of guide through it, which was created by the communication staff at the academies. And so the first part of the report explores the physics, the science of our field, and that's preceded by an introduction, which provides historical context, as well as providing an overview of what's in the report. We were asked to describe the connections between our field and other fields of science, technology, and society. And that's part 2 of the report. And finally, there is the question of what we need to do, what we, in the broad sense of we, need to do in order to realize the promise of all the intellectual excitement that's presented in parts 1 and 2. And it is this section of the report that contains most of our recommendations. The conclusion of part 1, of course, is about the emergence of the field itself. And the recommendation is about finding a home for this activity, or maintaining a home for this activity in universities. And it's complicated. You know, how do you capture the connections to other disciplines without losing the core? And then the remainder of the third part of the report goes through challenges in education, in funding, and in community building. Education was the thing that attracted the most attention from the community. We got the most input. And so we have a series of rather broad recommendations, but I hasten to add that these are unpacked with very specific recommendations as you go through the chapter. Similarly, when we talk about funding, although of course there are issues about the amount of funding, the larger issue that the committee identified was the structure of funding, that it is now that the field essentially has succeeded by adapting to the funding landscape, but now that the field has emerged fully, it's time for the funding landscape to adapt to the field, and there should be more structure that matches what we as a community actually do, rather than being fragmented. And again, this is a very broad and general recommendation, but it's unpacked with specific recommendations that address the individual agencies, as well as other dimensions of the problem, such as the support for theory, the support for PhD students, and so on. And finally, there's the concern of building an inclusive community, and we emphasize that inclusiveness is a very broad concept. It addresses issues of international engagement. It addresses the history of our own society. It addresses issues of gender. And again, this is something that these are very broad statements. They're there just to sort of catalyze discussion. There are lots of details. It is a 300+ page report. And so there is a challenge that the committee felt in getting recommendations to the point where they are specific enough to be actionable, but broad enough to leave space for the community to respond in ways that are context specific. I suppose education is the place where that's most obvious. Education happens in such a wide range of different kinds of institutions that it does not make sense for us to be prescriptive. On the other hand, you want to be specific enough that there are things people can do. So that's a kind of view from 30,000 feet of the report. I haven't tried to review all of the science. Of course, that is where all the fun is. But I suspect that a lot of the discussion would like to focus, that many people who came here want to focus on recommendations and what we can do. So let me end by remarking that the report is in some sense a celebration of the emergence of the field. We got to where we are in large part because of community input, and if any of the things that we say in the report, or rather that the report says, are going to become real, then the community again will have to act in order to make these things happen. Let me emphasize, the National Academies are not an advocacy body. It's an advisory body. So the committee expresses its view of the field and the challenges and so on. But if it's necessary to advocate for change to happen, then that's something the community has to do. So there's a real border there, and actually preserving that border is part of what preserves the authority that these reports carry, for example, with congressional staff. So it's important for us not to step over that boundary. But on the other hand, of course, the community is welcome and even encouraged to take up the cause as they see fit. So let me stop and let you guys drive the discussion. And you will, over the course of the thing, hear from all three of us. So I don't know, Nancy, how you want to
Thank you very much.
get started.
Yeah, that was a very nice overview. I think just before we open it up for Q&A, I'm wondering if either Peter or Olga would like to make a few additional comments about the experience or your perspective, or things you particularly hope to hear questions about today. Anything?
Do you want to go first?
Thank you, Peter. Well, I think Bill gave an excellent introduction, as always. It was certainly a fun experience. It was a lot of work, as Bill pointed out. Well, something maybe that I can reiterate is that essential part of putting together this report was community input, and the role of community obviously did not stop upon the completion of the report. And in this sense, we do look forward very much to questions from you guys, and also your thoughts and suggestions on how to implement the recommendations in the report, and just in general, your view of the field and how to make it blossom.
Thanks.
Yeah, let me also, Bill, of course, gave a masterful introduction, as he always does. I think one of the interesting things that we as a committee found, maybe we knew it in advance, was that the field is unusual, because if you look at the practitioners of the discipline, all of whom regard themselves as physicists, many of them find themselves living in other places. It wouldn't happen if you're an astronomer, you're in an astronomy department, or you're in a physics department. You know, with rare exceptions, would you be somewhere else? And that, of course, is both the strength of the discipline. It means that we've got our fingers in everywhere. But it does mean, actually, that if you happen to be you know, somebody who's working in a neuroscience department, or somebody who's working in organismal biology and anatomy department, both as physicists, thinking about a subject with a particular style and an opportunity to interact, if you were there, you barely meet each other. And this is something that came across both in terms of the funding and the way the discipline is organized, which is why I think that produced the sort of central recommendation, actually, that physics should actually take ownership of this. And that's what I think, you know, we felt really quite strongly about. So, and then there are many more details than that, but let me stop there.
Great, thank you. So the floor is open for questions. This is meant to be an opportunity to discuss amongst ourselves and with the committee members, and get their opinions on things and learn a bit more. So if you have a question, the nicest thing to do, I think, would be to raise your hand and ask it yourself. And if you are unable to do that, perhaps because of the environment in which you're in, or you just would prefer to type it into the chat, please do so. And we'll call on you and so on. I guess Okay, excellent. We have questions already. Super. I don't have to step in yet. Raghu, go ahead.
Hi.
Okay,
So first,
yeah,
oh, sorry. Can you hear
let
me?
me just start.
Sorry, I think Raghu had his hand up first.
Oh, sorry.
But, maybe I'm misunderstanding the order of the hands, but Raghu, and then I'll go to you, Jinhua.
Okay, sorry. Yeah, so first of all, yeah, thanks for putting together the report, which is really quite amazing, and also hosting this. So thanks a lot. And I have to admit, I haven't read all 315 pages. But one thing I was curious about, there's a section that mentions queries to different funding agencies, and it's pointed out that kind of the answers to those influence things in the discussion. So the queries are, I think, in Appendix C. Anyway, I was curious if any of the funding agencies kind of responded, like, I guess the short way to put it, did the funding agencies read the report after you guys made it? And did they have any particular comments on that, if so? Thanks.
That's an excellent question. So reports produced by the Academy have sponsors. And so in this case, the sponsor was the National Science Foundation. So they were actually briefed before the report was released. We've briefed different groups in different ways, not everyone. So we don't really know yet we don't have a good model of what's happening out there. You know, the Academy staff spends a fair amount of time trying to poke the system in various ways to figure that out. It's still early in the sense that, you know, it's been a couple of months, but also these have been some combination of the pandemic and the summer, right? So
Certainly, yeah.
A little tricky. So I don't think we have a status. I should say that, thank you, Chris, that in addition to briefing the funding agencies, there were briefings for the Office of Science and Technology Policy, which is, as most of you know, is in the executive branch, and for congressional staff. An example, so the clearest example of feedback was that when we went to brief the folks at OSTP, the first words out of the mouth of the senior person there was that regarding our recommendations about international engagement, we should be reminded that this administration is very different than the previous one, and that many of the things that we are saying about the importance of international exchange are things that they value very highly. And I think we have, I mean, quite independently of the report, I suspect we have seen a lot of movement on those issues over this year, let's say. So
Cool. Well, thank you.
Hey, thanks. Jen Wang.
Okay, so actually, my question also related. First, I really thank the committee for this great service to the community, and really, you know, I think the whole community was very excited about this really announcement, a new field. So my question is this, right? So, you know, for the funding agency, now they always say, if you go to a funding NIH, NSF, we are really recognize the importance of theory, computation. So we tried a lot, you know, we really encourage things. But then actually it turns out this kind of thing really works against our community. Reason because their definition of a computation thing is very different, right? They're very broad. Anything they use computer, use mathematics, they call this theory things. Then we are really diluted by huge community of informatics or this computer science people. So my question is how, actually I was on the NIH panel on physical oncology. So there is informatics proposal. Well, wait a minute, are this really physics, you know, really suitable for this one? They say, yes, they have decided that's it. So my question is how our community convey that message, you know, the program officer, they won't send their like immunology proposal to our like a cell biologist or you know developmental biology, but they will send a physics-oriented proposal to informatics people. You see the problem? You know, they definitely will. Their evaluation hours completely different. completely, right? Their criteria things. So how can we convey this message to the funding agencies to educate them?
Can I step in first? I'm sure that others have a point. Yes.
Yeah.
So
Sure.
Well,
Let me just ask you,
yeah.
would it be helpful for me to put some of the recommendations up in the background while you're talking? Or?
Yeah, actually, that might be great. Actually,
Let me see if I can.
I mean, I think the first one, which is a very direct response to what you said, John Hart, is that we recommended that NIH have a study section for biological physics, right? Okay. So that because one of the things what we found with NIH actually is that NIH does fund a great deal in our community, but it's funding them out of multiple study sections, multiple institutes. Right. So so we hope they'll take that seriously. Right. For one. And then of course the other things are a little less tractable. It's of course associated really with the structure of funding in the United States, where every branch of government has its own research program. I mean, that doesn't happen in most other places in the world. There's one or two places to go, right? So that produces, I think, special problems that you see in biological physics, because if you just happen to be working on the biosphere, depending on whether it's in the ocean or in the soil or in the atmosphere or in plants or in the human gut, it is naturally funded by very, very different sets of agencies. And without trying to redefine how they see their missions, it would be very difficult. But then I think another thing that comes out very strongly in terms of that, which we express in our report, is that the central agency for funding, if you like, the core of the discipline is the NSF. And the NSF has been quite successful in helping establish and fund this field. And loosely, it doesn't have enough money. And also its funding grant size is too small to be able to be really helpful for experimentalists. There are other comments, but I think it's a very good question, and it's something that we as a community need to continue to work on.
All right, thank you. Maybe I'll follow up on that question regarding the funding and the dispersion of biological physics into different communities, with one that's related to the academic side and teaching or claiming ownership of biological physics. So at our institution, like I'm sure at many, what comes down to is how many people are you teaching. That dictates in large part how much the university gives you in terms of operational budget and how you can justify new faculty members and so on. And because there are so many different disciplines in which biological physics, or more broadly speaking, quantitative biology, neuroscience, and so on can be taught, do you have suggestions about how to sort of uniquely claim some of these very interdisciplinary areas into a physics department, and or how to collaborate with other departments so that physics still keeps its sort of finger in the pie?
Maybe I can say a few words. Nancy, so of course you're right, and the report points out that biological physics has strong connections to efforts in many different departments. But at the same time, it is essential to have the home for biological physics in the physics departments, in particular because this reinforces the approach to biological phenomena through the physics mindset. And this emphasizes the intellectual tradition of physics, with the value of unifying principles, the value of simplification, sometimes oversimplification. So in no case we want to say that the efforts in all these other departments are irrelevant, and in fact quite the opposite. But it's essential to position biological physics as a core component within the physics community and have its home in physics departments.
I think one of the recommendations that embodies what Olga's just been saying is that, we break the whole discussion is broken into, things you can do inside the physics department, things that you need the rest of the university for. And one of the key points is that, the proper acknowledgement of the roles. So first of all, that at an intellectual level, as was just said, physics has a special role to play even in these interdisciplinary activities, right? And then it's also important that the university administration find a way of being sure that the dollars follow that role, right? So what's the, there's it's Clemenceau, right? War is too important to be left to the generals. It might be that quantitative biology is, well, never mind. You can finish the thought. I think that when there are many examples of, large efforts in quantitative biology on university campuses in which somehow the community of physicists inside physics departments who are interested in biological phenomena are sort of that it doesn't quite work, right? It either doesn't work intellectually in that they weren't there at the beginning of discussing what the plan is, or they were there intellectually, but then when the budgets get assigned, well, this is a biology initiative, so the money flows to the biology department. And that's not a problem for the physics department to solve. It's not a problem for the biology department to solve. That's a problem that deans and provosts have to solve. So we say that. I don't know how you get them to listen, but at least when you have this problem, you can now point to a report that says that.
Yeah. Great, thank you. Margaret.
Thank you very much. Margaret Chung. And I have a question about how the panelists think about leveraging DOE's user facilities. I read the report with great interest, and particular comment that caught my attention is that DOE actually hired the largest number of biological physicists, but we don't call them physicists. And that happens to me. I actually recently moved to a national lab, but my position is either computational biologist or chemist. There's no physicist in my directory. And if you think about the physicists, usually we have national labs, they work on large scale experiments. But in DOE per se, the user facility that rally around biomolecular science is really a Pacific Northwest National Lab out of 12 national laboratories. And there's very little, I would say, connection between our APS community with these experimentalists at the national laboratory. As a result, I feel there's a disconnect between us because we are thinking about how to organize departments, but departments individually have limited resources. If we have some kind of a housed core facilities that in AMSL, they will able to spur sciences and churning out data analysis from their experiments. So how do the panelists think about this in this angle?
So shall I try taking a first stab at that? It's a complicated story. So this is comes a bit from my own history about having spent time at Argonne. So I think one should break this up into two things, right? So the first one is the user facilities. And there are sort of two aspects to even within the user facilities. One is, if you look closely, you discover that biological physicists are actually very heavy users of the user facilities. You will know this, but others don't. Okay.
Yeah.
We discovered that in terms of large computational projects and so-called insight projects, which are using the world's largest computers to solve big problems, about 10% of them are actually in biological physics. And these are just competed across the field. So they're there. Now, the comment we make there is that when DOE, however, is considering building user facilities, they don't consider the biological physics community as part of their community. We just tend to show up later and use something which has been built with the purpose of someone else. So, the big synchrotron is a good example of that. When they were first built, there wasn't much thought that they'd actually be used for protein structure. I mean, this was a long time ago, but it turns out that's now a major community. But it's still the case that DOE isn't constitutionally required to consult this community when it's thinking about what next to build. And that gets to the second part of the problem, which is fundamentally that DOE is a mission-driven agency, and the overlap of its mission with biology is actually very small, and it feels really very tightly constrained about how it can do that. Okay, and I think we view that it's just ridiculous, actually, that the agencies are so constrained to fit into a narrow box that they can't effectively collaborate. And that this community as a whole should be pressing hard, probably through Congress, to actually make these things happen. So PNNL is a sort of perfect example of someone who managed to get a foot in the door with UNZL to be able to do this. And there should be opportunities elsewhere, but the pressure on that, it won't come because we ask the agencies to do something. It'll come because OSTP tells the agencies that you must collaborate. So the place to exert your pressure, and I think this is something for APS actually, is actually in Congress and in OSTP on that issue. I think that's sort of a, sorry about the long answer. And I mean, Bill, we discussed this at great length. So
yeah, let me add one thing, which is I think that the general recommendation about funding concerns the need to have structures that reflect what's actually happening in the community, as opposed to trying to squeeze the community into and fragment the community into existing structures. And in some ways, the DOE, although it comes at the end of our discussion because we address it in the context of user facilities, in some ways, it's sort of the poster child for that problem. If you ask the DOE who uses this facility, they have a categorization. They could be a physicist, they could be a chemist, they could be a biologist. But it is not possible that the person who uses the facility is a biological physicist in the sense that they're asking physics questions about something that comes from the living world.
That is true.
Okay? If it comes from the living world, it's biology. It goes in a box over here. And if it doesn't come from the living world, it doesn't go in that box. And that's not what's happening out there in the community, right? And so the DOE has provided support historically for many things which were fundamental to the origins of our community. In the discussion of science, we spend a bit of time highlighting both classical and modern work on photosynthesis, a large part of which was funded by the DOE or its precursors, precursor agencies. But somehow that didn't become a biological physics program, right? It's fragmented in different pieces. So,
but what should we do?
Say the same thing over and over again, but
yeah. But what should we do if we sit on, or is it like terabytes of those images, data that is basically very valuable for our community? How can we get it? How can we distribute those things from EMSL to the community? And how did the community know we have these things? Obviously, there's a disconnect there. I see it because I get to see both sides. But I myself do not have the authority to say, okay, let's create a program to allow all the physicists from our community go dig in all these goodies, like grabbing candies from a candy store. How should APS or DBIO help this? I have no idea. I see this opportunity, but I don't know what to do.
I mean, I think you just have to continuously highlight it. So there are, obviously, there are examples of where you might say that some of these things have been done more successfully. I mean, there's the, I forget the big protein database, which is coming out of California, which is, which is supported by DOE. But it took a very long time to get that set up, and it had to be defined by a set of rules which are quite complex and live within the parameters of the agency. So I agree, it's just not hard. But I do think it's something that DBIO should be talking about. It's something that you can actually take as a community as a whole, and push it out there. And there are cracks appearing in this, right? So that it's also worth noting that in some of these cases, NIH as an agency might be welcome to invest. So there are plenty of cases now where NIH co-invests in big DOE facilities to get something done that they want. Right? But as Bill said, all of these things involve, carefully taking the community and fitting itself into a particular box made by the way that the agencies think about themselves. And, it would be nice if one could gradually get down those barriers as well.
Oh, thank you. That's very helpful.
Great, thanks. I see we've had a couple of, a few people join us recently, so welcome to you. We're just, we had a brief presentation about the report from the Decadal Survey, and we're just asking any questions we might have of these people who have spent a lot of time thinking about this and writing a report. So please don't feel shy about jumping in with questions. It's great to hear from you. I'm curious from a sort of structural standpoint. We have the recommendations and report from the biological physics community, and how integrated were the different physics disciplines in terms of like some overarching final report? Like, did you sit down with the astrophysicists, the particle physicists, and so on, and try to synthesize some broader physics thing? And maybe I should know this, but I have not read the report in detail.
So let me channel the National Academy staff members that we've talked to. So this also is overseen by the Board on Physics and Astronomy. Interestingly, although there remains sort of growing enthusiasm of the different agencies to have to support the decadal survey of subfields of physics, it used to be that there was a volume that was a kind of overview of the whole thing, and that volume has not been produced in 20 years. So there is no synthetic volume, for the simple reason that it does not appear to be anybody's. Well, it's a little bit like the conversation we were just having about agencies seeing their mission. Who would pay for doing that? It's not, but just to be clear, right, we on the committee don't get paid, but the staff does, and there's a lot of coordination required in order to do this. And so it costs something. And so, but yes, I mean, it's an interesting question. Maybe I had mentioned this in an offhanded way to Francis Hellman, but I wanted to do it, maybe the APS should advocate. I mean, if the APS thinks this is important, it's actually kind of a big undertaking, so we don't want to presume the answer. If the APS thinks it's important to have a synthesis of the different decadal surveys into a view of physics as a whole, and that conversation would be useful for the community, then that is something that the American Physical Society could sensibly advocate for. I mean, and uniquely, right? I mean, who else would ask? So
that's a really good suggestion. I see we have one of our DBIO reps from the council, Daniel Fisher, is here. I don't know if this has ever come up on the council meetings while you've been there, but might be something for consideration. And Margaret, as chair of DBIO, may also have the opportunity to advocate for that. I think it would be interesting personally to have a synthesis, but then one worries about how to prioritize the different subdisciplines and whether this becomes a sort of a fractured discussion rather than a cohesive one.
It just it hasn't come up while I've been on there, and I guess Bill was the previous
Yeah, so
representative.
we can vouch for about 6 years of it not coming up.
Yeah.
Okay.
Doesn't quite reach back to the previous decadal survey, but it's getting there.
Yeah.
I mean, I think it might be that doing it, directly with through the NAS physics and astronomy board, since studies start there, would be one option. Even though it's a very clumsy process, and I guess I was involved at the beginning of getting this physics of life one started, and it was, yeah, as Bill said, it was a large number of years ago, and I think for Herbie Levine and me, who were both on the board at the time, it was I think our main activity. There's very little on that board that connects with biological physics, because it tends to be based on much more is on big funding issues and things. So I don't have any good suggestions otherwise.
Okay, thanks for the input. Anyway, it's something we could keep in our minds as a community. And I don't know what the other panelists feel, if this would be something that you think APS ought to advocate for, or seeing the work that goes into these individual surveys, that it would just be not worth the reward for the amount of work it would be.
Well, at least sitting down together and discussing this with astrophysicists and condensed matter physicists and so on will certainly help with the recognition of biological physics as part of physics, right? So we don't just talk among ourselves, but also with colleagues in other subfields of physics.
And yeah,
I think
yeah, I have to say, so one of my jobs as the chair of the committee was to present the report to the Board of Physics and Astronomy. And I have to say, obviously it is not the case that all fields of physics are represented on the Board of Physics and Astronomy. That would be an overstatement, but many are. And, it is, the response was actually quite enthusiastic, and people were excited to see that, things, the idea that so everybody knows these things have been bubbling along, but the idea that the community has arrived at this point was something that people were excited about. And so, yeah, I think there's I think Olga's right that it's one thing for the biological physics community to say, hey, we've arrived. It's another thing for a larger physics enterprise to say this has arrived. And that would certainly be valuable for us, right?
I think there is one context where maybe across the physics, that's something one could push to start, which is on the educational side, particularly the undergraduate education. I mean, probably many of you have faced the issue of trying to get some biological physics into the physics curriculum, and with responses like, okay, well, we can put a course in there, or maybe there's going to be a biophysics option, but then the students are not going to be relieved of any of the upper level 1950s style or earlier courses that they normally have to take. And I think it certainly would benefit the physics community as a whole of having a look at what is basically the standard undergraduate physics curriculum has been for a long time, and how one might integrate newer things into it and also drop some of the older things. So that's, I say, one potential context. I'm not sure what the right avenues towards that would be.
And that is, just to reiterate, that is a sort of consistent message of our chapter about education, is that most of the things that would be good for us would be good for physics. I mean, it's not just generally. I mean, there is this gap between what physics is today and what's taught to undergraduates, and it has been allowed to become wider and wider and wider as the field has advanced. And there needs to be some sort of reset. And in biological physics, we have our own reasons for being worried about that. We have our own particular things that we're concerned about, but the problem is much more general.
Indeed. Other questions or comments or suggestions for discussion? This is really nice to hear a number of different voices and input. Okay, there's a question in the chat from Jing Chen. Has there been any discussions about extending biological physics education further to pre-college?
We have a short answer, which is that, you know, I think everybody on the committee felt that this was important, but it was just beyond our, remit. I think that I think that many of the things that we say about the integration of examples from the living world into the teaching of physics could be rephrased one level down, maybe 2 levels down, I don't know. But we didn't have the wherewithal to say anything specific about that, so we regretfully punted.
I wonder if you have any suggestions for how to start to develop an example of biological physics things that could be integrated through the curriculum. Like, we teach biological physics courses, and at least at my institution, I think we do a really good job of integrating life sciences and physics into our first year course for life science students. But I was discussing with a colleague the other day, and we don't put any of this into our first year physics for engineers and physical scientists. And there's very little places we have biological physics in our curriculum. And, you know, obviously we should, this is the recommendation, but it would be lovely to have some sort of little examples, a database of these, or something that colleagues who have no training in biological physics would feel comfortable adapting to their courses. And I'm wondering if you have any suggestions about how this could happen, or what agency or group of individuals could take responsibility for this, if it would be a good idea.
Well, I mean, I think just a model of that is that very few places now is there a course in nuclear physics taught. But that doesn't mean that physics students leave with a physics degree without having seen some nuclear physics, because if you're teaching quantum mechanics tunneling, well, you know, there are some obvious examples, right? So that the trick is to find those. And I agree, this is something that if we could develop as a whole in the community, to get some experience with that, to develop some modules, just some simple ideas, and get them out there, and then have people slot them in, because that's in the kind of place where a typical lecturer will have some freedom to add and subtract things from the course. It's in terms of the examples they use to talk about the basic principles. But as Bill said, there's also a kind of a deeper gulf between how we present physics as a whole. But I think one could get in the way, I think.
So I think in that spirit, beyond the recommendations that we make, there's text where we kind of go through a litany of examples. Just to pick a couple, you know, I think every statistical mechanics course does the random flight polymer, or some version of it, as an example of entropic elasticity. The best experiment showing that that theory is correct involves picking up a single molecule of DNA and pulling on it. And as far as I know, that example is almost always taught without any experimental. I mean, there's some vague notion about rubber bands, for which it's not really a terribly good model, but there really is a very explicit test of all those theoretical ideas using the methods and examples from the biological physics community. We talk about most of the colors that you see around you come from absorption bands that are incredibly broad, and yet somehow you learn quantum mechanics and you think that absorption line, first of all, they're absorption lines, not absorption bands, and their width comes from the lifetime, right? And you'll have a hard time explaining the color of your shirt that way. In fact, almost all the colors around you. So there's a whole, there's the wonders of low Reynolds number mechanics, right, where time reversal invariance is restored. Anyhow, there are lots of beautiful things which really connect to the core of the physics curriculum. But we also, please.
Yeah, these are beautiful examples of how to incorporate examples from biology to stat-mech or quantum mechanics. The report also mentions examples that can be very easily incorporated at an earlier level, so the pre-college level. For example, walking, flying, and swimming are beautiful examples to illustrate principles of mechanics, or neuronal activity, very relevant to biological electricity. So the report does have a recommendation specifically regarding a collective effort to, collect together these examples and to create some kind of database, right? But also there's a lot that we can do individually with relatively, little effort is in the physics classes that we teach.
I think this is, I mean, I agree with all those things just been said, but I think they're way too unambitious. And I think if it only creeps into the physics curriculum in an incremental way, that's a major problem. I think the example with nuclear physics does not introduce, since I did do a full nuclear physics class when I was a student, does not introduce really much by ways of thinking to the ways that one has in the physics courses. There's many examples that come from biology do that. Even just the power of simple phenomenology and having to make simple models and so on, which tends not to get taught. The whole thing of dynamical systems, where you say from the beginning you don't know the equations, are much more natural in biological context than they often are in physics, where we pretend, most other physics areas where we pretend we know the equations. So I think there's the aspect of sort of really the different ways of thinking. And then there are the cultural aspects of it. There's exciting areas that exposes people to all kinds of interesting things. There are modern research makes them maybe recover from taking biology in 10th grade and hating it. Never taking a biology course again until they get to graduate school and end up as professors in departments with bio in the title, quite a number of people. So I think, there's sort of many aspects of it, but I really think that one has to push in the direction of it replacing some of the current physics courses for at least a substantial fraction of physics majors, if not for all of them.
Daniel, of course you're right, and the examples that we've mentioned is certainly not the only thing that the report suggests, right? So I guess we meant to just say that this is a first and simplest step that we can make to at least. Right. No,
I agree
but you're absolutely right that there's this issue that physics students often, usually in fact, do not even see the connection between physics and the fun and beautiful phenomena of life that they do appreciate as fun and beautiful, right? And so just pointing out to them that there is this connection, I think it can be very eye-opening. So I can certainly say from my own experience as a student, in particular student in theoretical condensed matter physics, it for a long time until my postdoc years probably did not actually occur to me that I can do something meaningful as a theoretical physicist that is relevant to biology.
Yeah.
So these were two separate universes. Yeah. And so just to point out this connection early, I think this can be quite powerful.
Yeah. But I do think there is just a caution is that one of the drawbacks of incremental approaches is they can sometimes make it harder to make big changes.
So the report, I would say I would add two things to the discussion, and then I want to shut up because Catherine's had her hand up. But one is that there is a couple of lines of the report that are quite strong that point out, for instance, that we hardly teach anything in the core of undergraduate physics that happened after 1950, perhaps even 1930. And this is to be contrasted with our friends in biology and computer science, who, to first approximation, don't teach anything that happened before 1950. And there is a perception that physics is the science of the previous century, and biology and computer science are the science of the current century. And if we keep teaching this way, it's not surprising that people have that impression. And so we say that. And so obviously there's a call for something much bigger, but we felt that we needed to be concrete about some set of things that were underneath our umbrella. The other thing I would say is that both by the coincidence of who happens to be here from the committee and the people who have spoken so far, you've heard theorists' views. It's also true on the experimental side that laboratory courses are not what they should be. And for example, there's been this revolution in microscopy which reaches right to the heart of our understanding of things like the diffraction limit. And that it is a limit only in certain senses and not in others, which is very profound. The fact that you can, harness the forces produced by light, which after all were not completely understood until the 1960s, in order to manipulate things on the micron and cellular and molecular scale. I mean, these are beautiful pieces of experimental physics that touch fundamental questions in our understanding of light, and they're largely absent from modern laboratory courses. And they also happen to be places where you could connect very well to things in the living world. So,
I would love to continue the discussion along this vein, but we have a couple of people with hands up. So let's go to them, and we can always hop back to this. So Catherine.
Hi, Catherine Crouch from Swarthmore College, and actually I'm going to weigh in on continuing this conversation. So I just wanted to say that, first of all, a number of us, some of whom who are on this call actually, have been involved in the process of reforming and generating a national database of curriculum for physics for non-majors who are life scientists. And we have begun the process of convening a group of folks who are interested in developing such a similar resource for biological physics. And specifically to consider the range of possibilities for curriculum sharing, ranging from the incremental, because at some institutions, all you can do is the incremental, to the more radical. So Daniel, I'd have a lot of fun chatting with you more about some of your ideas about this. So anyway, please feel free to reach out to Patricia Soto or Bob Hilborn or me if you're interested in delving into this at more length. And I'm also just really interested in hearing anything else that people bring up in the context of this call. But we have, from our experience with working with the physics for life science majors curriculum, we know that convening a community is a really key part of this process. And so we're just sort of looking for people who are interested in being part of that process right now, and would love to hear from any of you.
That's fantastic to hear about, Catherine, and to learn about. It would be great if at least one of you on the group is here for our call later this month about teaching biological physics to also help spread the word. And
I believe all three of us have already, or well, actually, I don't know about Patricia, but I know Bob and I have already signed up for that one as well. So we are looking forward to joining for that.
Hopefully you can find some keen people. And just speaking on behalf of APS DBIO, if there are things we can do to help you get the word out, or if we want to host one of the monthly events targeted at that discussion, which is a bit more specific than the broad theme of teaching biological physics, then we're happy to help with this initiative. I think it's really important.
Let me add from the committee's point of view, one of the things that I hope we're careful about, certainly wanted to be careful about, is the enormous diversity of contexts in which physics teaching happens. And so one consequence of that is that if you want to make progress, if we as a community want to make progress, it really has to be a rather general notion of we. Because, the vast majority of people who take freshman physics take it at a community college, just to give one number. So if you want to change, and some of those people, of course, go on to get degrees at four-year colleges and universities, and some of them even find their way into graduate school. But the fact of the matter is that the majority of freshman physics courses are taught at community colleges. And so if you think that the introductory physics course needs to be changed in a way that, among other things, acknowledges the physics of life as a topic and a set of examples and so on, then you need to be talking to a completely different set of people than you would talk to if you're worried about preparing people for, if you're worried about the right kind of introductory biological physics course for PhD students.
I'll just respond that that is exactly the kind of strategy we've already undertaken with the Living Physics portal, which is the resource library and community hub that we have for the physics for non-majors, in which we do have community college representation and so on. And so I agree absolutely that that's a critical element of widespread success. And it's one of the big challenges, but it's also one of the things that makes this kind of thing fun, is trying to figure out how do you create something that's flexible enough that that you can bring in such a broad group, but that can actually get going somewhere. And then the only other thing I'll just say is that, you know, this is super early stages, and we are, you know, this is not to say that we have like a finished project or anything like that. It is just saying that some of us who've worked on this for Physics for Life Sciences are excited at the prospect that we might be able to use what we've learned there in this direction. And I saw the request to put the link in the chat to the portal. It is, the thing I will say about the portal is that we got a 5-year grant to set it up 5 years ago. And we sure didn't get as much done starting in March 2020 as we thought we would. And so it is not as far along as we had hoped it would be, but I'm sure that's true of what most of us have been doing for the last couple of years anyway. So anyway, I don't want to redirect this discussion or anything like that. Just wanted to make sure that anybody who's excited about this, you know, that we find a way to connect to you somehow.
You. All right, we have been here for about an hour or so, and I know everyone's time is valuable, but it's also really nice to be able to have this opportunity to hear from our team. I'm wondering if anyone in the audience has any last questions, please don't hesitate to ask them. And meanwhile, maybe we'll just ask the panelists, give you a last opportunity to say something. Is there anything that hasn't come up in the Q&A or in the presentation that you'd like to stress or communicate to us that you'd really like us to go away, think about, or act on?
Peter, Olga, if you want to give that a try, or.
Well, I'll say something very brief. I mean, I think that firstly, I know, speaking for the panel as a whole, we had enormous fun preparing this report, because actually the community was very helpful about providing the information that's there. And I just want to hark back to what Bill said, is, you know, we've done the best with it we can. We now give it back to you. And we hope that there are enough hooks in this proposal that when you're, you know, talking to your dean or talking to your congressman or talking to someone else, you can wheel this thing out and you can point to something and say, this is what the community would like you to do. And that historically has been one of the best ways to use these things. And I hope it's fit for service in that way.
Excellent, thanks. Olga?
I think we had excellent questions here at this meeting, but of course, these questions and these points of discussions are a very, very small subset of what has been reviewed and discussed and recommended in the report. And so I would highly recommend that you please find a time and look at the report. And I want to assure you that even though the report is essentially a book, you do not really have to read the whole thing to get the idea of some main points. It is, I think it is structured quite well and organized in a way that allows you to go to find quickly, you know, the key points and the recommendations on the specific aspect that you're interested in, for example, education, or for example, funding. And there is somewhere even a summary of all the conclusions, findings, and recommendations. So I hope that the volume of this report will not discourage you from looking at it and from using it, for example, as you talk to deans or as you make your own develop your own ideas.
Thank you. And Bill, last word. to
Yeah.
you.
So to echo what my colleagues have said, I mean, the report comes in sort of three parts. Let me encourage you to have fun with the first part. I mean, describing the science was a joy, I think, for all of us, trying to get our arms around the incredible breadth of the field. And that's something which we think is sort of fundamental to everything that comes afterwards. That, once upon a time, you might have been able to believe that physics and biology, one could illuminate the physics of some small part of life. But what we've seen emerge in the last couple of decades is that physicists have sort of spread all over, from single molecules to ecosystems, animal groups, take a pick, every scale in between. And it's really an extraordinary, it's an extraordinary activity. It is no longer a small activity. One of the things we discovered, and I think came as a surprise to everyone in the report, was the number of people who get their PhD in physics who say that they're doing the physics of living systems or biological physics today is the number of people who said particle physics 20 years ago. So we're not a small marginal activity, right? And we're growing. And then in terms of addressing the challenges that we've been talking about, as was mentioned, this is sort of laid out by education funding and community building, and I think what you'll see and what came out in the discussion today is that there are things that we can do individually. The next time you teach, try to work in one example in the course, and that should not be seen as mutually exclusive with more grand efforts to change how we do things as a community, both in the classroom, in funding agencies, and so on. And I guess maybe on a sort of personal note, I was actually quite struck by the breadth and depth of concerns about education coming from our community. And I think that's a kind of tribute to the community, that we care about how we teach. And there is, as has been explained, a challenge in turning that into action, and turning it into action, which is more than the sum of the parts, requires some cooperative efforts. But hopefully we will find a way to do that. So thank you all.
Great. So please join me in thanking Bill and Peter and Olga, and for coming today and interacting with us in this great way, and also just to the whole community that put this report together. It's really valuable for our community, so thank you for the immense effort it took, and we really, really appreciate it. So with that, thanks all for coming and joining us, whether you were just a set of ears or a questioner, and hopefully we'll see you at future APS DBIO events.
Bye-bye.